Hey everybody, welcome to lesson number 12, CIS 17A. So today it's a very simple lesson. It's probably the shortest of all these semester's lessons. As you can see, it's only going to cover about 10 pages in the textbook. And we're going to be rewriting one of our previous lab assignments where we used arrays, and we look for the smallest value, the biggest value, and the average value in the array. But today we're going to do the same thing using something called a vector. So what is a vector? Let's go over to the textbook. So a vector is something that comes from what's called the standard template library. Um, the standard template library contains a whole bunch of stuff that is not actually a part of the C++ language. It was stuff that was later added to the language. So things like storage containers. There's an array class that you can use instead of the built-in arrays like we learned about in the last two lessons. Okay, so a vector is in many ways like an array. All right, so let's go ahead and skip down here and see how they're similar and how they're not similar. So a vector, like an array, holds a sequence of values. So, and all those a sequence of values or elements. I don't like the word values necessarily. Think of it more as like a sequence of elements. All right. A vector stores its elements in continuous memory locations. We talked about with arrays how contiguous memory locations are important because it helps performance. And just like with an array, you use the subscript operator to access the individual elements of a vector. So how is a vector different? Well, with an array, we had to say how many things were going to be in the array at the time that the code is compiled. So we couldn't do something like ask the user to enter in a number and then use that number for the size of the array. We had to have that either as a literal or as an integer constant that was positive. So with vectors, you do not have to declare the number of elements that the vector will have when you create it. Also, even if you do declare a size to the vector at some point, if you add something to the vector when it's already full, the vector will automatically increase in size. So if we made a vector of size 4 and we added a fifth thing to it, it would just make the vector larger to accommodate that new value. And then last but not least, vectors can report the number of elements that they contain. So recall when we were using arrays with function calls, that if we used a two-dimensional array, we would have to actually declare a global constant int. That global constant int was then used when you called the function like we did in the last lab. And that was remember that was the size, the number of columns. Or even when we just called a regular, not a regular, but even when we called a function using just one array, we would all have to pass in the size of that array as well, because if you're going to use a for loop inside that function, it needs to know how many times to loop. So with vectors, we don't have to do that. The size of the vector is built into the vector itself. All right, moving on. If you want to use vectors, just like if you want to use strings, you have to include the vector library into your program. So you're just going to simply put that right below when you use IOStream. You're just going to make sure you put include vector. Apparently I can't Alt-Tab correctly tonight. All right, there we go. All right, so that's all you got to do if you want to use vectors. To declare a vector, it just looks a little bit different. We put the word vector, but then in angle braces, we put what it's a vector of. And then we can put any data type here. So integer, float, strings, and later when we learn about classes, we can put classes or objects in here as well. So we can have a vector of objects. All right, so you put keyword vector, what it's a vector of, and then we put the name of the vector. So in this case, the person chose to call the vector numbers. All right, so let's go ahead and do that real quick. So we'll just come down here and we'll make, just like the book, we'll make a vector of integers. All right, and I'm going to call it num. So that way when we index into the array, we can just put num1, num0, num3. All right, so there's our instance of a vector called num. And in this case, because I didn't put anything after num, it's just an empty vector. It literally has no elements in it. All right. So how do we add stuff? Let me do this really quick because I'm put these next to each other. There we go. All right. So if we want, we can go ahead and when we declare the vector, also say how many elements are in the vector. So in this case, they're saying that we want to have 10 things in the vector when we create it. Now, normally because of the very nature of vectors, that the idea is that you don't know how many things are going to need to be stored in the vector at compile time. It's at runtime that probably the user is going to provide how many things that they create, or when we don't know how many things the user is going to create. So that's the whole point of using vectors. So this isn't very common. Usually you can just make it empty and then add stuff to it. All right, now when you do this, when you just say make 10 things, you should know that it initializes everything to 0. And it doesn't actually say that in the book, but you definitely should know that for a quiz or an exam, that when you do specify the size of the vector in parentheses at the time you initialize it, that those all get, that numbers will be initialized with the value of 0 and everything. The way you index into it is the same as with arrays. So if we did this, the first thing in the vector would be numbers 0, and the last thing would be numbers 9. So the same thing as with arrays. Starting index is 0, last index is size minus 1. Okay. If you want to specify what to initialize, you can do that by adding a comma, and this would make it so that instead of initializing all 10 elements to 0, it would initialize all 10 elements to 2. Another interesting thing, if you want to copy vectors, that's built into the vector class, and all you do is put the name of the vector into the initialization parameter, and this will copy everything from set 1 into set 2. So you'll now have two vectors with the exact same contents, one vector called set 1, one vector called set 2. All right. So here's just some examples of declaring vectors. Nothing too complex going on here. So you can see you have floats, vectors of strings, vectors of ints, vectors of characters. This one's initializing the first 25 to capital A for whatever reason. And then like we just saw, copying one vector into another vector. All right, storing and retrieving values. So as it mentioned earlier, you use square braces, or the subscript operator, to read or write to existing elements in a vector. So let's see an example. So this is the same example from last time. Hours and pay rate are the names of the two different vectors. And here we're going to go ahead and initialize it to 5 employees using this. And then index sort of acts like an employee ID number. So it's that same idea that you can have parallel arrays, and then when you loop through, the index acts like the ID number for that person. So we see down here, we're going to go through the employees 0 through, well, the book likes to do this. They don't like to use employees 0 through 4. They want to have employees 1 through 5, so they're adding 1 here. But so they're just going to ask to get the number of hours that employee 1 worked, and then here's the magic. So you're going to, because they've already been, the vectors have already been, oh God, the word I'm looking for, declared here. Declared is not the right word. Anyways, because we've created the arrays here, and we've already made them have 5 things in them, we can just write directly into using the vector using the index here. So in this case, it's going to start off at 0. So this is going to be hours sub 0. And then we're going to ask for the pay rate. It's going to read that into the pay rate vector sub 0. And then we just loop through and do that for hours 0 through 4, pay rate 0 through 4. All right. Next, you're going to calculate how much to pay the person. So how many hours did they work times how much we pay the person. So each person can get paid by a different rate and work a different number of hours. And then we're just going to print out, like in the example down here, what the person made. Must be down further. There we go. All right, so then we just print out how much that person should get paid. Okay. All right, so hopefully that wasn't too confusing of an example of vectors being used. Let's go ahead and just do it. Let's go ahead and just mess around with some vectors over here. So let's go ahead and make a vector with 3 things in it. So now we have num 0 through 2, and I can do this. I can say cin to num 0, and then let's just copy this. And then down here, I guess I could have done that in a for loop, but should have done it in a for loop, I should say. And then let's go ahead and just print everything out. Oh, they haven't shown you yet. Okay, I'm going to wait until the book talks about it. But like I said, the vector knows how big it is, but I'll go ahead and just hard code it in here. I plus plus, and we'll come back and change it to show. We'll cout num I with an end line. All right, so let's see. So this is going to ask me to read in 3 numbers, and it's going to print back what I entered into the vector. All right, so here we are. It's just waiting for that first cin. So let's go ahead and put 3, 45, and 6. And it's going to print back 3, 45, 6 in that for loop. Okay, so there's an example of entering data into a vector and reading data out of a vector. So you can see it's just like we would do for an array. Now earlier I said that it's not very typical to do this. So, and by the way, this is an error, right? You shouldn't be, because those elements don't exist. This will crash your program if you do this. All right. Let's go back to the book and see what it wants to talk about next. Okay, this is a good place to go next. So when you want to add something to the vector and you don't know how many things are in it, like I said, you normally start with an empty vector. You use the pushback member function of the vector class. And you do that by using this little dot notation here. So again, we haven't talked about classes or objects yet, but behind the scenes, that's all a vector actually is a class. So if you don't know what I'm talking about, that's okay. All right, so this little dot operator allows us to access any of the what are called methods or functions associated with the vector class. So it's going to use the pushback function and pass in the argument of 25. And what that's going to do is it's going to insert it to the back of the vector. So let's see if they give an example down here. I was hoping they'd give a different example. I thought they did give a different example. Well, I'll show you instead since they're not. Okay, so let's go ahead and see how we can do this and see what happens. So num is empty. So we're going to use pushback. So notice when I hit the dot, this little menu pops open. These are all the different functions associated with, actually not all the ones on there. These are all the different functions associated with the vector class. All right, we're going to push back. Let's see, I can hit tab to auto-complete that. And then put a number in. Okay, and then let's just go ahead and copy and paste that a couple more times. Let's put in the number 4, and let's put in the number 234. Okay, and then I shouldn't have deleted that for loop. It's all right, you guys want to watch me write that code again, don't you? Yes? Okay, I knew it. Okay, and again, there's a trick here, but we know that there's 3 things, so we'll see later how we can let the vector tell us how big it is. And we'll do that same line of code. Okay, so this is the exact same example that I gave just a moment ago. The difference being that before we started off with a vector of size 3. This time we're starting off with an empty vector. We're using the pushback function call, or member function, to push back these numbers. So let's go ahead and give this one a try. Whoa. Okay, so this time there was no CN statements, right? So I didn't stop and wait for me to enter these. It just picked them up right from here. So, and then it printed out the contents. So we can say they match 3404, 234. Okay, so that's how you can add things. Now also note the order that it printed the numbers. This is why it's called pushback. So remember, it's printing out from 0 to 2, right? So notice that the last thing that I pushed into the vector went to the back of the vector, right? So in other words, this is going to be at num0, this is going to be at num1, and then this is going to be at num2. So that's why they call it push back. It pushes the value to the end of the vector. All right. So here they're going to redo the whole hours and pay rate vectors, but they're going to do it using pushback instead. So instead of, notice that there's no constants up here that say that there's 5 employees. Down here you actually read in how many employees there are from the user, and then you loop that number of times in the for loop using pushback to fill up the vectors with data. All right. And you can see the output is the same. The only difference being that it starts off by asking how many people there are. All right, here's what I've been waiting for, the size member function. So using the size member function, you can actually get the number of things that are currently in the vector. So over here in our for loop, what we could have done instead of just saying 3 is we could have just used the size function. And we accessed that the same way that we got the pushback function, which is using the dot operator and then putting size. Now, this is a function call, so because we're calling the size function, you have to put parentheses in there. It just so happens that with the size function, we don't have to pass it any information, so that's why we just put an empty pair of parentheses. All right, so let's go ahead and see if this does the same thing it did before. Boy, it's taking a long time to compile every time I run it. What's up with that? Okay, and there you see, got the same exact results as last time, except for instead of using the number 3, we let the vector itself tell the for loop how big it was. So pretty nifty. I love vectors. When I code, I use the heck out of these things. They're very, very flexible, and I like them. I like them. I like them a lot. All right, let's go back to here. Okay, so there they are, just showing you the same thing that I just showed you. Okay. Okay, just showing you examples of pushing things back and then using the size. And that's worth mentioning, is that's another big difference. Oh, and they just kind of did snuck something in here on us. They're actually passing a vector to a function. So that's a pretty big deal. I should definitely stop and make sure that I give this some love, because you're going to need to know how to do this for the lab. So when you pass a vector, this is all you have to put, is you put the vector keyword plus what's in the vector. It's a vector of what? It's a vector of ints. Notice that just like with anything else in the prototype, you don't have to put a name. But down here in the function definition, we do have to put the name of the vector. They called it vect in this case. I usually just put v. So then there you go. So that's kind of nice. We don't have to, because we're able to use size, we don't have to additionally pass in how many things there are. So recall with arrays that you have to have both. You have to have the array, and then the second argument is usually going to be the size of the array passed in from the function call. Right? So that's kind of nice. That makes it easier to pass a collection of objects to a function if you use vectors instead of arrays. All right. If you want to take something out of an array, you can use the pop back function, and that will remove whatever is at the end of the vector. So down here, they're going to push in 1, 2, 3, 3 being the last thing in, and then they're going to call pop. So 3 is going to be the first thing to go, 2 is going to be the second thing, and finally the number 1 will be the last thing to go. All right. You can use the clear method to wipe out the contents and reset the vector back to empty, being completely empty. And then you can use empty to return true or false, whether the vector does have elements in it or whether it's an empty vector. Okay, now I think that's the end of this lesson. Okay, here's what are we doing? Calling a function called average, setting total 0, average. If the vector is empty, then the average is 0. Otherwise, it's not empty. Use a for loop and size to go through and add up everything in the vector, and then the average is equal to the total divided by the size. So again, you can see how nifty these little size member functions are for calculating stuff. This is also part of the lab, by the way. You don't have to do is empty, though. You don't have to do error checking for the lab. You just do this right here. All right, and that's the end of the reading. Oh, here's some other vector member functions. Okay. All right, you don't need to know these for the test. I'll double check, but if you do need to know them, I'll make sure to highlight it later. So let's go ahead and go back over and talk about something that's not in the book. This is just coming from your instructor, and this is very, very, very important with regards to using vectors in functions. All right, let's going to really switch gears here and talk about using vectors in function calls. All right, so I'm going to go ahead and declare a function that doesn't return anything, and we're going to pass it a vector of ints. Okay. What did I miss? I'm missing something. Oh, it's not vect, it's vector. There we go. All right, and then let's see. Let's go ahead and copy this for the function header down here in our definition. And then remember, we got to give it a name. Come on. All right, there we go. V. Okay, let's go ahead and just do a simple loop. Print everything out. Actually, no, let's not do that. Let's not do that. Okay, let's go ahead and just put some stuff in the vector. So we'll put in 1, 2, and 3. Very creative. Okay, now down here, let's do this. So we know we got num0 through num2. So then down here in the function, let's go ahead and just alter the value of the first thing and say v sub 0 is equal to 254. Then up here, after we've pushed stuff back, let's call the function num. Okay. And then let's see what happens when we come out of that. So we're going to go ahead and print out the contents of num0. Oops. All right, there we go. All right, so just a quick run through here. So we're pushing in 1, 2, 3. We're going to call our function. It's going to set v0 to 254, and then we're going to print out the contents. The question is this: is num0 still equal to 1, or is it equal to 254? What do you guys think? I'll give you a second here to decide. Okay, that's enough time. All right, let's run the program and see what happens. And as you can see, the value is 1. So remember with arrays that when you call a function and you pass it an array, that it's implicitly a pass by reference, not a pass by value. In other words, you're not copying the entire array and messing around with the copy of the array in the function. You're actually accessing directly the contents of the array in the call. But look what happened here. This is the opposite. So we have a vector, we call the function, and in here, we changed it to 254, but when we came back, it was not still changed. In other words, this is doing a call by value, not a call by reference like with arrays. That's a huge difference. Let me tell you why. In order for this to happen like we see it happening here, let me give myself a little more room. Come on. Just want you to be able to see everything better. There we go. All right, so what's happening here is it's actually creating a copy for it to place all the stuff from here into it. So I am creating an entirely brand new vector called v and copying num into it when I do a function call like this. That is extremely, extremely, extremely bad, because you may think, well, what's the big deal? It's just copying three things. Later, when we learn about objects and classes, the way to think about an object or a class for now is just as like a big collection of data, a big collection of different variables. And in a case like that, you now have several instances of that class or object in the vector. And let's say that it has 1,000 variables per object, and you got 10 things. That means you have to copy 10,000 variables into this version of the vector down here. That's really, really, really bad. You should not do that, and there's no good reason to do that. Why is there no good reason to do that? Because what we can do instead is this. First off, let's go ahead and make this copy the way what an array would do. So all we have to do to make it so that it is altering the original, no, not the number 7, is to put the ampersand there and make it a reference call instead of a call by value. So now when we run this, we should see that number 5 or number 0 has been modified in the original, and instead of printing 1 like it did last time, this time it's going to print, or should print, 254. All right? So what happened here by making it a reference, instead of it copying the entire vector into this vector, v is now just really referencing this vector up here. So what happens behind the scenes is you're calling it with num, and it's passing the memory address of this vector to the function, so that when we use v, that's all that's getting passed to the function is a memory address. One memory address, that's it. So in the example I gave a second ago where we're copying like 10,000 different things into a copy of the vector, you would just pass one thing, the memory address, that's it. So much, much, much more efficient. Now you may say to yourself, hopefully, what if this is just something that's going to print something out? What if we don't actually modify this? So in other words, what if we're just doing something like this? We're just going to go cout v0. So I don't need to actually modify anything. I'm just reading the data. So I don't want to give a function the ability to potentially modify my vector if all it's doing is reading the contents, but it doesn't need to change any of the contents. So that's bad, right? In that case, what you want to do is make this a const vector reference. So by putting the keyword const, it prevents the function from doing something like this, like we did just a second ago. v0 is equal to 3. So you can see I get the little red squiggly line. It's telling me, hey, this is a constant. You can't modify it. All right, so in summary, you should never just pass a vector by itself. You should always pass it as either a reference if you want it to be a pass by reference, or as a constant reference if you want it to be like a read function that doesn't modify the contents of the vector. All right, so just to run this, let's go ahead and get rid of this so you guys can see it work one time. And then we're almost done. This video is a lot longer than I thought it was going to be. I'm talking too much. All right, and there you go. So it just passed it as a constant reference, and then we printed out the value there, and it was 1. Okay, you guys? All right, let's go ahead and wrap up the lab, and then we're all done. So let's see. So you're going to write 5 functions, one called fill vector, that's going to ask the user for how many scores they want to add to the vector and then initialize it. So inside of this function, you are going to both ask the user and use the pushback method to, in a for loop, to fill up the vector. So this is going to be passing, so when you call this function and pass it the vector, you're going to have to pass it as a reference. Not a constant reference, a reference. Okay, next. For print vector, all it's going to do is use a for loop to print out the contents of the vector. Since this is not modifying the vector, you need to pass this as a constant reference. Same thing with find, min, and max. They're not modifying the vector, so that's just going to, and I didn't specify here whether it should return the min value or whether it should just print out the min value from inside the function. I leave it up to you, however you want to do it. Find average, same thing. It is not modifying the function or the vector, so this should just be a constant reference. So the only one that's going to be a reference is the first one. Everything else is a constant reference to the vector. Okay, and we've done these functions in the past with arrays. So, well, we didn't use functions with the arrays to do it, but you guys have done that before, so I'm not going to review it. All right, you guys, and that's everything that you need to know to complete the lab. And then here's, of course, a test run. So how many scores you want to add? The person chose 5. So then we call fill vector and then use the for loop plus the size function from the vector to use in a for loop to read everything in. Okay. And then again, you're going to have to use pushback to do that because these are going to be, the vector should initially be empty in main. And then we're going to use our print function here, or call our print function here, and then call the smallest, call biggest, call average. And like I said, you can either just print that out from inside the function or return it as a value and then print it out in main. Yeah, okay. That's it, you guys. All right, so as usual, good luck with everything. Hope everybody's doing well. If you get stuck on anything or need any help, make sure to reach out and ask me whatever you need help with. All right, good luck, everybody.